Okay, so we're going to start off. I want to do a quick recap of what we did last lecture on measurement. And then the very last question in the chapter, I told you to try on your own, and we would discuss it today. So we spoke a bit about converting units and how to convert from millimeters, centimeters, decimeters, meters, kilometers, and so on. And I showed you that like almost like number line thing that you can use as a tool to help you. Okay, I really do think that's quite useful. We also spoke about when you're working at the perimeter, all you are actually doing is pretending you're this little ant crawling around the outside edge of the shape. How far do you crawl? You crawl up, you crawl across, you crawl down, you crawl back. Maybe it's not a rectangle, maybe it's an odd shape where there's all sorts of different ways in which you can crawl. But at the end of the day, you've got to make sure that you have measured the outside of that entire shape. And I do suggest that if you struggle with the more complicated shapes, the more complex ones, that you maybe take a highlighter, and as you write the number down for one of the sides, you highlight that side, you've counted it, so that you don't leave anything out, okay, in the more complicated shapes. And we looked at formulas for squares and for rectangles. We then looked at area, and we also looked at the formula for circles, for the circumference of circles. We then looked at area, and we looked at a formula for the area of a square, we looked at a formula for the area of a rectangle, and we discussed how to do the area of triangles. Remember, whether they're obtuse or whether they are acute angled, it didn't matter. Remember, you need your perpendicular height, which comes from the vertex to the base, and if it was an obtuse angled triangle and the perpendicular height was over here on the outside of the triangle, it doesn't matter, as long as it's the height of the tip to ground level. Okay, so this is just to recap what we did last lecture. We then spoke about, and circles, which is pi r squared. We then spoke about how to do the area of irregular shapes, and we looked at how to break those irregular shapes into squares, rectangles, triangles, or circles. Okay. Volume, which is three-dimensional. I said to you, work out the area of the base. The base will always be a square, a rectangle, a triangle, or a circle. A square, a rectangle, a triangle, or a circle. Work out the area of your base and times it by the height. And they gave you a whole lot of formulae to work out volume. But at the end of the day, if you just remember that it's the area of your base, which is always a square, a circle, a triangle, or a rectangle. If you work out the volume of the area of your base and times it by the height of the shape, you don't need to learn these formulae off by heart. You just need to remember the formulae for the areas. We then looked at converting volume into liters, because every container, every three-dimensional container can hold liters, can hold liquid. Okay, assuming it's a closed container. And we said if your answer is in centimeters cubed, so no matter what your measurements for your volume are, if you then convert your answer into centimeters cubed, 1 liter is 1,000 centimeters cubed. And remember, I taught you how to convert as well. When it's length, you just convert once. When it's area, you have to do the conversion twice. For volume, 3 times. So you convert the volume 3 times into centimeters cubed if it's not already. And then for every 1 liter is 1,000 centimeters cubed. So then you can just do a straightforward conversion with ratios. Okay. On page 74 was a summary of all the formulae that you need to know. Remember, perimeter, you technically don't need to know any of the formulae, you just need to add all the sides. Formulae sometimes make it quicker if you can remember them. Area, unfortunately, you need to know those formulae. And for volume, you don't need to know all those formulae as long as you know the area formulae times by the height. Okay, so it's only really the area ones that you have to know, and of course, circumference of a circle. Okay. And then we did a couple of applications, and we spoke about applications, and I said to you that I wanted to do exercise 4.7 with you today. Again, I asked you to have a look at it. Did any of you manage to have a look at it? Okay. I asked you to have a look at it, and we're going to look at it now. Okay, so Make this a little bit bigger. Okay. You want to cover the walls of your bedroom with wallpaper. Okay. The bedroom has a floor. So if you look at your bedroom, there's hang on. If you look at your bedroom, I just want to go back into this page again because I don't know what I did there. If you look at your bedroom, you have a floor like that, and your floor happens to be a rectangle, and your floor is 4,3 by 3,4 meters. Okay, that's your floor space. The walls are all 2.5 meters high. Now, are you going to wallpaper your floor? No. But they've given you this for a reason. And they've also said ignore the fact that there might be doors and windows. We're just assuming this is a box of a room with no doors and windows, because then you have to, I'll explain to you just now what to do with doors and windows, okay? They've given you your floor space. They've told you every wall is 2.5 meters high. The reason they have done that is if you had to open your walls and almost like open up this box and lay it all flat, this wall will be 2.5 meters high, but will have a floor along the ground. It will be 4.3 meters long. This wall will also be 2.5 meters high, but along the floor over here, it will be 3.4 meters long. So you can now work out the area of the rectangles that actually form your walls. If you think of the walls in this room, you need to know how long the wall runs along ground and then how high the wall is. So they've told you what the floor space of the room is so that you would know what the length of each wall is and then the height. So we're looking in 2 dimensions, it's area. So if we looked at the first one, the first wall that I drew would be an area of 4,3 times by 2,5. Okay, which happens to be 10,75. And you must say meters squared. I'm not putting it in here. It's too small a space. I will put it by my answer, but you should put meters squared. The area of the other wall I drew was 3.4 times by 2.5, which is an area of 8,5. Here I can fit in the meters squared. It's an area of 8,5 meters squared. Now, because this wall along the left and this wall along the bottom of my picture are both identical in length and height to the 2 walls I've already done, I can work them out and then add them all, or I can just times that by 2 and times that by 2. It's totally up to you. Okay, but at the end of the day, my area would be, so if I did it as 8,5 plus 8,5 plus 10.75 plus 10.75, if you didn't want to times it by 2, it would be, the total area you need to wallpaper is 38,5. And it's meters squared. It's still area. Even though it's not one area, even though we're working in a 3-dimensional shape, we're working out what we call surface area. We're working out the area of each of those walls. We are not working out the volume of the room. So it's still in meters squared. What would happen if there were doors and windows in the calculation is the following. Let's say, for example, we had one door over there, which measured 1 by 1.5, let's say. And let's say in this wall over here, we had a window which measured 1 there and 0.5 there. And the other 2 walls had no doors and they had no windows. What I would have to do is I'd have to work out the area of the first door, 1 times 1.5, which is 1.5. And I'd have to work out the area of the window, 1 times 0.5, which is 0.5. Add those 2 together, which would give me an area. That red area in total would be 2 meters squared. And I would then subtract it from my 38.5, and my area then would only be 36.5 meters squared. So if there were doors and windows, you would need to work out their areas as well. We can't wallpaper them, therefore we take them away. All right. Very, very, very important. That's why they've said, assume there aren't any. Okay. Question number 2 says you've moved into your newly built house. And here is your house, and you've got paving and a swimming pool and some grass. And you want to cover the entire grass area with grass. You have a budget, and there's a cost for purchasing the grass. So the first thing we would need to do is we would need to work out what kind of area am I planning on grassing? Yeah. So it's area. So you've actually got 2 options in how to work this out, because we just want to work out the area now. For me, what I see as the easiest option here is to work out the area of the total rectangle. Okay, so I would say my total area is 30 by 40, which is 1,200 square meters. Okay, that's where I would start. What I would then do is I'd work out the area of the pool. Okay, so the area of the pool, which is 6 by 4, which is 24 square meters. Okay, I would then work out the area of the paving. Area of the paving, which is 15 by 5. 15 by 5, which is 75 meters squared. The house is a little bit more complicated because it's not a regular shape. So for the house, I'd say area of the house is, and I would draw in a line over there. Okay, and I'd say the area of the house, the first shape is 10 down by 15 across. You all see that? It's 10 down by 15 across. So I would say it's 10 times by 15, which is 150. Plus, there's also this smaller area underneath, which is 5 across, but do we know what it is down? Yeah, if the whole thing is 15 and that is 10, that extra bit must be 5. So it's 5 by 5, which is 25. And 150 plus 25 is 175 square meters. And then what I would do is I'd say, okay, the area of the grass is, and that's when you take out your calculator and you say it's 1200 minus the area of the pool. You get your answer for that, which is 1176. And from that, I'm going to take away the area of the paving, which leaves me with 1101. And from that, I'm going to take away the area of the house. And I'm going to get an area for my grass of 926 square meters. Now, your other option, which I'm going to show you in blue on this picture, your other option is to just work out the area of the grass and to literally try and break this up into pieces that you can work with. I don't think it's the easiest option. Sometimes that would be the easier option, so I'm showing it to you as an option. There are times when that is the easiest way to figure out the area. For me in this case, because breaking it up gives me so many different shapes, for me in this case, working out the area of 1, 2, 3, 4 shapes and taking it away from my big area is a lot quicker than working out the area of what I would see as 1, 2, 3, 4, 5, 6, 7. I get 8 shapes that I would probably break this grass area into and add them all together. For me, the way we've done it is the quickest, but I wanted to show you where the options are. Okay, so now I know what the area of the grass is. So now I'll go back and I say, all right, the fact that my garden budget is 15,000 Rand is actually at this point irrelevant. I want to see what it's going to cost me to put down the grass, and then I'll worry about my budget. So what you do is you say, okay, these are the options I have. What is it going to cost me? If it falls within my budget, I go, great, and I go for it. If it falls outside my budget, I renegotiate. Okay, or I reconsider what I want to do. So if I wanted to get kukui grass, it's 15 Rand for each square meter. So if I want to get kukui, that would be my square meters, which would be a 9, times by 15, which is 13,890 Rand. Okay? Which is great. I can go for kukui grass. All right? What about the other option, which is the LM grass? Which is like a shade grass. So that would be 926 times by, and my price for this grass is 20 Rand per square meter. Now, if you've got a very shaded garden, kukui is going to die. You'd rather go for the LM grass. If you've got a very sunny garden, doesn't really matter which one you go for. And I get 18,520. At which point I pray that my garden is not a shade garden because I'm going with kukui. Okay. If they were both within my budget, I would then look at the quality of the grasses and make further decisions along those lines. Here's a straightforward math thing. Is it in your budget or isn't it? It's not. Fine, I can't do it. Okay. All right. And these kind of questions are quite common. Okay, where they ask you to work out the area of something within something else, and then you've got to do adding or subtracting in order to get the area you want. They could. Yeah. So what is the area of the grass? These are your options. It's quite a bit of work for a multiple choice, which is why also, just while I'm on that thought, and then I'll listen to you again. You know, they always say, I don't know, you work out how many multiple choices there are, you work out your time, and you work out how much time you have per multiple choice. Bear in mind the short ones should give you time for the long ones, because there will be very short ones and there will be very time-consuming ones. Yeah. They could. I would draw the figure. I've hardly ever seen that come up unless it's a really simple thing. You know, unless they say to you, you know, you've got a garden, square garden, which is 12 meters by 12 meters, and along the edge of the garden, all the way along the edge of the garden, there's a paved path of which is 1 meter wide. What's the area of the grass? Okay, so there it's really simple to draw the picture. I can't imagine they would ever give you something this complicated. Okay. All right. So that's the end of measurement. Okay. It's not terribly complicated if you know your formulae, and if you think, what are they asking me? They're not always going to ask a straightforward work out the area of a square. Okay. They might say, work out how many liters this container holds. So you know to do that, you first have to do your volume in centimeters cubed. Like you've got to look at the end point and think, what did I learn that brings me to this end point, if it's not a straightforward one? Okay. All right. Are there any questions on that at this point in time? You all good? Okay. I really have no idea what I've done with my screen and why it's so far over. No, I really don't know what I've done with my screen. Okay. So we're going to move on to equations and formulae. All right. Oh, before I move on to that, how's the assignments going? They're due this week, am I right? Huh? They are due this week. Did you all give you extensions? Get them out of the way, though, as soon as you can. We've done the work for them. Okay, remember, if you do have problems and you do have the time, I'm prepared to help you to figure out how to do the answer yourself. Okay. And next week, Monday. Okay. So this is our last lecture before your assignment's due. All right, but we're already on to the work for the next assignment. Okay. And that is equations and formulae. All right. We have learned how to deal with algebraic expressions. Up until this point, we've been looking at algebraic expressions. And an algebraic expression is where you've got a whole string of terms, all pluses and minuses and times and divides and brackets and squares and roots and whatever else they can throw into them. But in the actual question, there are no equal signs. You may choose to put equal signs as you're simplifying it, but the actual question does not come with an equal sign. And if there's a variable in an expression, you cannot work out what that variable is. That variable could represent anything. In an equation, however, when we deal with algebraic equations, which is what we're going to do now, in the question, it gives you an expression which is equal to another expression. And you are then able to solve for the value of that variable. Okay, we'll worry about formulas just now. So, for example, in this example, halfway down the page under 5.1, it says to you, 2x plus 3 equals 9. So you're going to sit there and you're going to think, okay, 2 times what number added to 3 is going to give me 9 as an answer. All right, and we call that doing it by induction. You're thinking, all right, 2 times 1 is 2, plus 3 is not going to work. 2 times 2 is 4, plus 3 is not going to work. 2 times 3 is 6, plus 3 is 9. Okay, I know x is 3. All right, we call it induction. The other way of solving an equation when induction is taking you too long or is too difficult is to move all your terms in the expression in such a way that anything that contains a variable is on the one side, and anything which is just a constant number is on the other side. Okay, and that's all well and good, but how do you now move these things? So what you do is you start off, remember BODMAS? You start off almost with the reverse of BODMAS. So you start off with the things that are added or subtracted first. Then we move on to things that are times and divided. Then we worry about exponents. Then we worry about brackets. Okay, so we're almost working backwards in BODMAS. And you move the things around the equal sign by doing the opposite operation. So if something is added and you want to move it, the opposite of addition is subtraction. Vice versa, if it's subtracted, you can move it by turning it into addition. If something is multiplied, the inverse of multiplication is division. And I know this stems all the way back to grade 7. You don't automatically change the sign. Okay, you just change the operation. So if something is times and I move it across an equal sign, I turn it into a divide. That doesn't mean I change it from a plus to a minus. I just change it into a divide. If something is added, you change it into a subtraction. If it is times, you change it into a divide. If something is raised to the power of 2, you turn it into a square root. If something's in a square root, you can take it to the other side by squaring. Okay. You always do the opposite, what we call the inverse operation. So in this case, I'm going to leave the 2x on the side where it is. And I'm going to take the 3 over to the other side. Now the 3 on this side is added. The opposite of addition is subtraction. And I'm going to get 2x is equal to 6. Now the x is still not on its own. There is a 2 in front of it. I need to get rid of that 2. The 2 is multiplied by the x. Opposite of multiplication is division, and 6 over 2 is 3. Okay. If when I moved my things, I ended up with more than one term on one side, in this case I had 2 constants, I add or subtract them, I simplify it. Okay. So that is what we call an expression, and it is very easy to solve for an expression. A formula is a kind of an expression, but a formula can contain lots of variables. For example, distance equals speed times time. That is a formula. Okay, it contains lots of variables. Where we use a formula is they'll tell us, okay, so a car was traveling at 120 kilometers per hour for 90 minutes. How far did it go? So I replace the letters with the numbers I know, I turn it into an equation, and then I solve. Okay, that's the difference between an equation and a formula. An equation is one variable. Sometimes, but we're not going into that now, sometimes it might have 2 variables. Remember simultaneous equations from school? Again, but you can solve for those variables. A formula, you are replacing the majority of the variables with numbers based on your research, based on your reading, based on the information given to you, and then you have an equation where you can solve for whatever's missing. Okay, subtle difference, but there is definitely a difference. Okay, another example, they don't always have no numbers. So for example, to work out degrees Celsius, if I'm not mistaken, if you want to convert between Fahrenheit and Celsius. I don't know if it's plus 32 or minus 32. Is it plus 32? This is your equation to work out to convert from degrees Celsius to degrees Fahrenheit. There are numbers in here, but you need to know one of them to work out the other. So if you're reading a recipe, if you're living in America and you read a recipe which says bake your cake at 180 degrees Celsius, you can replace the degrees Celsius with 180, and you can solve for the degrees Fahrenheit, and vice versa. Okay, if you're getting an American recipe, you do the same. So it's just another example of a formula where in this case there are numbers put in as well. Okay, so they're not always just letters. Now, they're teaching you how to solve equations by seesawing and trying to balance things and whatever. I really think you've done enough by this stage to, at school level, to be able to solve an equation by simply moving your values. Okay. If you need to read through this, you can read through this, but it's at a very, very basic level. Okay. What they do say over here, which is very, very nice to remember, is they say you can always check your answer for your equation. Which means if I go back to the one we were doing before, on the first page, 5.1, I worked out that x was equal to 3. What does it mean to check? It means go back to your actual question, 2x plus 3 equals 9. And I'm going to just take the left-hand side, and I'm going to say, okay, 2x plus 3. All right, if x is 3, 2 times 3 is 6 plus 3 is 9. Then I go to my right-hand side, and I solve that if I need to solve it. In this case, I know it's 9. Are my two sides the same? Then I know my answer's right. If my two sides work out to be something different, I know I've done something wrong. And if they give you a straightforward equation, if they give you a straightforward equation in an exam, and they want to know what the answer for the equation is, and they've given you options, you have two choices. Choice number 1 is to solve the equation. Fine. Choice number 2, if you're getting stuck on solving the equation, is to take the options they've given you and put them in and check. Solve the left-hand side with the option they've given you. Solve the right-hand side. If the two sides are equal, that is the one you choose. If the two sides are not equal, move on to the next one. Okay, so you can actually work backwards because it's a multiple choice paper. Okay, and because you've got all the actual possible answers there. Okay. If we look at this example that they've given us over here, I'm going to skip what they're doing, and I'm going to jump straight from here, b plus 4 equals 9, and I'm going to say, okay, I want to get the b on the one side and the numbers on the other. I'm going to keep the b where it is simply because it's easier. It doesn't matter which side you move things to. Equals 9. And this 4, I want to move over. It is added on the side. You move it over by changing the operation. Opposite of addition is subtraction, and b equals 5. And now you can go back and check. To check, I look at the left-hand side, replace the b, 5 plus 4 is 9. Look at the right-hand side, there's nothing to do there, it is 9. I know my answer is right. Okay. The same thing with number 2. Number 3 slightly different because it's multiplied instead of added, but we know the opposite of multiplication is division. I got an answer of 6. If I want to go back and check, 4k means 4 times k. 4 times 6 is 24. My right-hand side is 24. I know my answer is correct. Okay. In question 4, k is divided by 4. To move that 4 to the other side of the equation, the opposite of division is multiplication. So I'm going to multiply the 24 by 4. Again, I get an answer of 96. I can check. Left-hand side is k over 4. 96 over 4. What does that give me? It gives me 24. I know my answer is right. Okay. So, let's summarize it here for you. Where they say to you, these are your inverse operations. The inverse operation for addition is subtraction, for subtraction is addition. For multiplication is division, for division is multiplication, and what comes up often are squares with roots, or cubes with cube roots. Okay, those I've seen those come up quite a bit as well. which should also be in the summary. Okay. Example 5.2 is, the first one is exactly the same. We want to take the 3 over by subtracting. In 2, we want to take the 7 over by adding. In 3, we want to take the 2 over by subtracting. These are all exactly what you've done before. Okay. What I want you to do very quickly is exercise 5.1, and then we're going to go on to slightly more complicated ones. Okay, so you try this one on your own quickly. Okay. In A, x plus 4 equals 12. If I move the 4 over to the other side, opposite of addition is subtracting, and therefore x is 8. If I check, x plus 4, 8 plus 4, it is 12, and it's great. And you'll see, I'm keeping on reiterating these checks. You'll see when the equations get more difficult that the checks do become quite useful. Here, you can just see it. Okay. 6 plus x equals 2. I want the x to stay where it is. Even though the x is coming second, I'm leaving it where it is. The 6 has to move. Now, if there's no sign in front of the 6, or no operation in front of the 6, because it's right at the beginning, it is, it's positive. So because that 6 is positive, when I bring it over to the other side, it becomes a minus, equals, I forgot to put the equal sign in, you see, equals 2 minus 6, and 2 minus 6 is minus 4. And if I check, if I replace the x with a negative 4, 6 plus negative 4, 6 minus 4 is 2. Okay, with number 3, x equals minus 3, and it becomes plus 7, and minus 3 plus 7 is 4. 4 minus 7 is negative 3. 5x equals 23, so x equals 23 over 5. Multiple choice options. Do we leave it as 23 over 5? Do we make it 4 3/5? Do we turn it into a decimal? You look at your options, okay? And then the last one, x divided by 4, because a fraction means divided, x divided by 4 equals 10. You take the 4 over and turn it into a times, and x would be 40. Because if you check, 40 divided by 4 is 10. Okay, so here the checks don't look as useful, but you'll see now that they really are. I'm going the wrong way. Okay. In example 5.3, it's exactly the same as what we've been doing, except now they've got timesing and they've got adding and subtracting. So we've got a 2x minus 3. Remember, we're doing the opposite of BODMAS. We're going to first do the minusing or the subtracting, and we're going to say 2x equals 5 plus 3, so 2x equals 8. Then we're going to deal with the fact that the 2 is timesed by the x, and we're going to take that over to the other side and divide. Okay, so you're working backwards with BODMAS. All right. And with that in mind, and the fact that you do all seem to know what's going on with this, I want you very quickly to do exercise 5.2. Okay, so I'm going to use using invoice operations. I'm going to move my variables to one side and my constants to the other. So it's going to become 2x equals 6, and the 3 will become minus 3. I'm then going to add or subtract what I can. So 2x will be equal to 3. Then I'm going to get rid of whatever is times or divided by the x. So it's multiplied by the x, so I move it over by dividing. In the second one, I'm going to keep the 6x where it is. I'm going to move the 4 over, and because it's a minus, when I move over, it becomes a plus. Add what you can, and then I'm going to get rid of the 6. The 6 is multiplied. Opposite of multiplication is divide, and 30 over 6 is 5. Now, if I want to check, okay, so it's getting a little bit more complicated to check now. If x is 5, 6 times 5 is 30, and 30 minus 4 is 26. Look at the right-hand side, it's 26. I know my answer is correct. Okay. In the next one, I'm going to keep the minus 5x where it is. I'm going to bring the 4 to the other side, and because it was added, I'm now going to subtract. So minus 5x is equal to 15. Now, And this is the part that I find at school level often is done incorrectly. Okay. The minus 5 is multiplied by the x. Opposite of multiplication is division. So I'm going to now divide by that minus 5. Okay, all I've done is change multiplication to division. A positive number divided by a negative number is negative, and 15 divided by 5 is 3. And now if I want to check, negative 5 times x, negative 5 times negative 3 is 15, and 15 plus 4 is 19. I know my answer is right. Okay. Over on the next page, I'm going to leave the x over 7 where it is, and I want to take the 2 over by doing the inverse operation. X over 7 equals 11. Now, the x is divided by the 7. Opposite of division is multiplication, and x is equal to 77. And if I go back and check, my left-hand side is 77 divided by 7. What is 77 divided by 7? It's 11. My right-hand side is 9 plus 2, which is 11. I know I'm right. Okay. In this example number 1 is pretty much the same. I want to have a look at example number 2 here. We're on page 84. Okay. In this case, in all the previous examples, my x's have always only been on one side, and I've only had to move my numbers. In the case of question 2, I've got x's and constants on the left. I've got x's and constants on the right. Okay, I'm going to solve this twice for you in 2 different ways. Okay, the first thing I'm going to do is I'm going to take all the x's and move them to the left, and I'm going to take all my constants and move them to the right. Okay, so I'm going to keep the 8x where it is. That 3x is on the wrong side. There's nothing in front of it, which means it's added. I'm going to do the opposite of addition, and I'm going to take it over. Equals. I'm going to keep the 26 where it is. That 6 is on the wrong side. It is a positive 6. It is added. I'm going to take it across by subtracting. I'm now going to add all my like terms. If I have 8 x's and I take away 3 of them, I've got 5 x's. If I have 26 and I take away 6, I've got 20. The 5 is now times by the x. So opposite of multiplication is division. It should be 5 because I'm thinking ahead to my answer, which is 4. Okay. To check, if I look at my left-hand side, 8 times 4 is 32. And 32 plus 6 is 38. If I look at my right-hand side, 3 times 4 is 12. And 12 plus 26 is 38. Because both sides happen to be the same answer, I know that my x equals 4 is correct. Okay. Any questions up until that point? You all sure? So now we're going on to a slightly different concept when it comes to solving equations. Okay. And that is when we now throw brackets in. Now, because we've got variables and numbers in the brackets, we can't solve in the bracket first because they're not like terms. We can't add them. Okay? But, and I don't know if you remember this or not, if you do, just tell me, is a concept called multiplication by distribution, which says, and let me do an example over here. If I had 2 into 5 plus 4, and I followed BODMAS, it will be 2 times by 9, which is 18. Right? Or, let's say I couldn't add that 5 and 4 for whatever reason. If I said 2 times by 5, 2 times by 5 is 10. And then I said 2 times by 4, and 2 times by positive 4 is positive 8. I still get 18 as an answer. So mathematically, it doesn't matter if you add in the bracket and then times what's outside it, or if you times what's outside it and then add them if you can. Okay. This only works for multiplication. If there was a squared outside that bracket, for example, it's a very different story. You can't just square each number. Okay, this only works for multiplication. We call it multiplication by distribution. So if I go to this question, okay, x plus 3 multiplied by 2 equals 18. Okay. I can say 2 multiplied by x. And 2 times x is 2x. I can say 2 multiplied by positive 3. And 2 multiplied by positive 3 is positive 6, and that equals 18. Now we're back to what we're familiar with. Bring the numbers to the one side, bring the x's to the other side. So I'm going to keep the 2x where it is, and I'm going to say 18. Opposite of adding 6 is subtracting 6. So 2x is equal to 12. Now the 2 is times by the x, so the opposite of multiplication is division, and x equals 6. If I now wanted to check my answer, I first look at the left-hand side. X plus 3, it's really a 6. 6 plus 3 is 9. 9 times by the 2 out the bracket is 18. The right-hand side is 18. I know my answer is correct. Okay. So now, if you look at exercise 5.3, A is pretty much straightforward. Multiply the 5 into the bracket, multiply the 4 into the bracket. B is very straightforward because all you have to do is move your variables and then add or subtract. C is the same as B. D is awful because D, I've got brackets inside brackets. And before you can solve this, you first need to deal with those brackets inside brackets. So you first work with your very innermost bracket and deal with that. Once you've done that, then you deal with that. And the same on the other side. Few minutes to quickly try these 4, please. Okay. D was absolutely awful. Okay. But I'm going to start with the innermost bracket first. Okay. Which is that minus, which goes there and goes there. That's my starting point. So I'm going to still have the 5x minus 3. I'm still going to have the bracket x. But minus times positive 3x is minus 3x. Minus times the negative 4 is positive 4. And that first very inside bracket has now disappeared. I'm only left with 1 now. Equals. I'm going to do exactly the same thing over here. I'm going to take the minus 3 into there and into there. Always start with your very inside brackets. So that'll be 2, bracket, 5x. Minus 3 times 1 is minus 3. Minus 3 times negative 2x is positive 6x. And that innermost bracket has now disappeared. Now I've got to deal with my next bracket. So I'm now going to do minus 3 times x, minus 3 times minus 3x, and minus 3 times 4. So I'm going to have 5x minus 3x plus 9x minus 12 equals. And on this side, the 2 goes into each of those. And it's going to become 10x minus 6 plus 12x plus 5. Plus 5 is not affected by that bracket. Now, x's to one side, numbers to the other. That one stays, that one stays, that one stays, that one moves, that one moves. Okay? 5x minus 3x plus 9x minus 10x minus 12x equals. On the other side, that one stays, that one stays, that one moves. Minus 6 plus 5 plus 12. If I've got 5 x's and I lose 3 of them, I've got 2. If I gain 9, I've got 11. If I lose 10, I have got 1. And if I lose 12, I have got negative 11. If I have minus 6 and I gain 5, I've got minus 1. Minus 1, gain 12, and I've got positive 11. X is equal to 11 over negative 11, which is plus over a minus is a minus, and 11 over 11 is 1. Minus 1. If I now want to check this, okay, And again, given on your calculator, it's actually not difficult to check. But if I wanted to check this, I'm going to rewrite the equation because I can't see it. 5x minus 3, open bracket, x minus open bracket, 3x minus 4, close bracket, equals 2, open bracket, 5x minus 3, open bracket, 1 minus 2x, close, plus 5. Okay. I now want to check. X is minus 1. So I replace that with a minus 1. 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 So what I end up with over here is 5 times negative 1, which is negative 5, minus 3 into minus 1 minus negative 3 minus 4. That's my left-hand side. And on my left-hand side, if I solve this now, I have got, inside that bracket, minus 3 minus 4 is minus 7. That minus 7 times the minus in front becomes plus 7. Minus 1 plus 7 is 6. 6 times negative 3 is negative 18, and minus 5 minus 18 is minus 23. On the other side, 2 into minus 5 minus 3 into 1 plus 2, because a minus 2 times a minus 1, plus 5. And I must close that bracket also. Okay. 1 plus 2 is 3. 3 times negative 3 is negative 9. Minus 5 minus another 9 is minus 14. Minus 14 times 2 is minus 28, plus 5 is minus 23. Both sides are equal. Given your calculator and how your calculator works, all you have to do is wherever there's an x, put a bracket and a minus 1, and it will do it for you. There's no excuse not to check. Whenever you solve an equation and get an answer, check. You should be getting every single equation sum correct, because you can check. And because you have the advantage of checking with a calculator that does BODMAS. Okay. All right. So that is the end of equations. All right. Are there any questions on equations at this point in time? Are you all okay? So what we're going to do now is take equations one step forward to what in school you called literal equations or formulae. They're just equations with lots of letters. Okay. If they give you an equation like this, and that's, yeah, AT equals V minus W. No, that is not the initial equation. Ah, here's the initial equation. The initial equation is V equals U plus AT. V equals U plus AT. And they want the A to be the subject of the formula. Now, what I do when I do this at school level is I actually say to them, write what you need to make the subject of the formula in a different color, because then you can track it, you can follow it. I want to get that A by itself. The A is on the right hand side. The A has got a T multiplied by it and a U added. The furthest away from BODMAS, the furthest away from the variable is the fact that I've got a plus U. So I'm going to get rid of that plus U, and I'm going to take it over to the other side, and that is what I now have. I now have A multiplied by T left on the right-hand side. I want A by itself. So the other way, the way to get A by itself is to say, I've got to bring the T over. The T is multiplied by the A. The opposite of multiplication is division. And I divide everything on the other side by T. Okay. It does help. You don't have to rewrite it in color. You've got to highlight it. You can just highlight it. But it really helps if the letter you want on its own stands out. Okay. If we look at example 5.7, I want the Y by itself. So I'm redoing these even though the solution is there, simply because first of all, they overcomplicate things a little bit, and also you can see while I'm writing. I think you follow better. I want in this case to make the y stand out. The y is what has to be the subject of my formula. And this is to show you that you can do it with a highlighter. You don't need to rewrite it. So I want this term with the y by itself. In order to get it by itself, I've got to get rid of the negative 3x, and I do that by changing the operation. I still want that y by itself. So in order to get the y by itself, I need to get rid of the 2. It is multiplied by the y, so the opposite of multiplication is division. I'm going to take this a little bit further because given that I would accept that as an answer. I think that is actually the correct answer, because we usually want to make things as simple as possible. But given that you have multiple choice options, whenever you have a fraction with lots of terms on the top and only one term on the bottom, you can split them up so that the 4 is over the 2 and the 3x is over the 2. Okay? It's not something I generally do, but you have multiple choice options here. They can do this to get their answer. 4 over 2 simplifies to 2. 3x over 2 doesn't simplify at all, unless you make it 1.5. So they could give you, as multiple choice options, they could give you that as your answer, but they could also give you that as your answer. And that's why I'm showing you that you can split it. Okay. If I was teaching this, I would accept the first one as a preferable answer. You need to know how to do both. Okay. Any questions up to there? You're good? You're sure? All right. And here they've shown us the answer. Sorry, what they could also do over here is they could then rewrite it and say that your answer is y equals 3 over 2x plus 2. So they could change the order as well. It's the same thing though. Okay. If we look at number 2, y equals minus mx. No, that is absolutely not what's written there. It is y minus mx minus c equals 0. And they say to me, they want me to make y the subject of this equation. Okay, that's fine. I want to make y by itself. This one's actually a really easy one, because all I have to do here is say y equals mx becomes positive, the c becomes positive. Do you recognize that equation? What is that? Straight line. Remember the straight line graph? It's a straight line graph. Y equals mx plus c. Okay. In option 3, I want a by itself. The only way to get a by itself is to get rid of the square root. And what's the opposite of square rooting? Squaring. So a equals b squared. There's your answer. Okay. In the next one, there's the question. So the first thing you want to do is you want a by itself. So the first thing you want to do is get rid of the c, and then you want to get rid of the b. Okay, as I said, I'm skipping out the steps where I really do think they overcomplicate things. Number 5, I'm going to do with you. X plus y over z, it should be an x, equals t. And that's not a t, that's a 4. Equals, that's a better t. Okay, x plus y over z equals t. What do we want by itself? We want the y by itself. So I'm going to highlight the y. Now, we've got a problem with this fraction. I cannot get rid of the x. Because remember from the beginning of this course, I said that the numerator of a fraction is considered to be bracketed. And if this is in a bracket, I can't get rid of anything till I've got the bracket isolated. So if this is in a bracket, I can do nothing till the bracket stands alone. Okay, exactly. My numerator is divided by z. So the opposite of dividing by z is timesing by z. Remember, your letters should be in alphabetical order. So it should be tz, not zt. Okay. Now that that whole bracket stands alone, I can get rid of the x, and I can do that. Or, as an alternative in your multiple choice, they could give you that, where it's actually the exact same thing, but they've just moved the terms around. The x is still negative, the tz is still positive. Can't move your signs around. They can't give me x minus tz. That is wrong. Okay, but they can swap them around. Again, I'm giving this to you because we've got multiple choice options. If they gave me these two, y equals zt minus x, or they gave me y equals minus x plus tz. Those are essentially exactly the same thing, right? Which one would you mark correctly as your multiple choice option? Y? Y, the bottom one? Alphabetical order. My Z and my T in the first one are not in alphabetical order. My Z and my T in the second one are. Alphabetical order is preferential. It's more correct. Even though, remember when we learned multiplication right at the beginning as well, we spoke about the commutative and associative rules of multiplication. It doesn't matter what order you times in. We still write them in alphabetical order if we have that as an option. Okay. If you look at number 6, I'm just going to do a couple more with you. These are just all the different possibilities. If you look at number 6, and I'll do number 6 orally with you very quickly, they wanted that b as the subject of the formula. A square root, a numerator, it's all considered to be as if it's a bracket. I can't do anything with it until it's on its own. So the first thing we do is take the t over, it's divided, so we take it over and multiply. Then the square root still treats it as a bracket. I can do nothing till I get rid of that square root. Opposite of square rooting is squaring. We have to square the s and the t, which is why they've bracketed it and squared it. Okay, now I want to get rid of the b. So I've got two options. I can say a equals st all squared minus b. That's my one option. Or a equals minus b plus st all squared. Or a equals s squared t squared. I get rid of that bracket, minus b. Or a equals minus b plus s squared t squared. Again, all of those are possible options. Which one is actually the preferential out of all of them? Which one is the most correct out of them all? The last one, because I have no brackets and b comes before s. So I've actually put into alphabetical order. But they could give you any of these four, and any of these four are actually correct. Okay. Again, I'm just showing you these options because of the fact that if you presented it to me in any of these forms, I'd give you the marks. But although the bracket isn't great, it's better without the bracket. But if you gave me the last two, I'd give you the marks. But if you were multiple choice options, the last one's the best. In 7, we want h by itself. So they took the a over. Then they got rid of the square root by squaring. Then they got rid of the 2 by dividing. And you could have that option, or that one without the bracket is better. Okay. And in the very last one, we want x squared by itself. Opposite of squared is square root. Okay. These are all very much the same. Here you want r by itself. So first they got rid of the 4 by timesing. Then they got rid of the pi by dividing. Then they got rid of the squared by square rooting everything. Okay. Exercise 5.4 is the very end of this chapter on equations and formulas. You have a choice. Do you want to do these 7 questions now, and we'll mark them, or would you rather do them at home and we'll mark them? I don't mind. We've got 5 minutes left, so the choice is entirely up to you. Okay, do you want to do them at home rather? General consensus? Rather do them at home? That's not a problem at all. Then I'm going to stop now. And next week we're going to start with marking these formulae, and then we're going to look at straight lines.